So we're moving on to lesson 2.5, which is somewhere between lesson 2 and lesson 3, but wasn't given its own lesson, so I decided to add it in. So we're identifying functions from relations, relations being any set of ordered pairs. So we're going to be given a set of ordered pairs and decide if it's a function. So we'll be given the definition of function here too. You see that I've already some things highlighted here, but it says Mrs. Heinel asked 3 members of her class their favorite color. The mapping shows below some possible results. So when she asked Amber, Tim, and Kayla, they all said red, blue, or green. She asked these 3 students, and they all had their own favorite color. When she asked these 3 students, Elena has 2 favorite colors, and these 2 students have 1 favorite color. A function is a special relation in which each member of the domain is paired with exactly 1 member of the range. If in the mapping above, Elena chose 2 different colors, so that one would not be a function, meaning that domain had 2 range values. So let's look over here. Mr. Morgan asked his students how many pets they have. Some student responses are shown in the table. So they wrote down 1, 3, and 6 for us. So complete the mapping. Well, 1 and 2 go together because they have 2 pets. Student 3 has 5 pets. And student 6 has 7 pets. That's a lot of pets. Is it a function? Does each member of the domain have only 1 range value? Yes. Each domain value has only 1 range value. Suppose student 8 has 2 pets, so they redrew our mapping. Make a mapping of the diagram of this situation. Is this a function? So 1 still has 2, 3 still has 5, 6 still has 7, and 8 has 2. So so we have to figure out, does each x or domain go to only 1 y? 1 only goes to 2, 3 only goes to 5, 6 only goes to 7, and 8 only goes to 2. So this is still a yes because each domain has one range. It becomes an issue when they have 2 arrows coming out of the same domain. So let's check out over here. We're going to make a mapping of the diagram for each situation, then determine whether each is a function. So what if they only go to 1? So students were asked about the number of cell phone minutes they use. Some of the responses are shown. So I'm going to abbreviate these students or the domain: Sarah, Max, Jacob, and Rebecca. Sarah used 275. Max uses 220. Jacob uses 350. And Rebecca uses 275. Is it a function? Do these only have 1 arrow coming out of them? Yes. Each domain has 1 range. Students were asked what are the names for their pets. Some responses are shown in the table. So Kiara, this person, awful names. Kiara has Tiny as a pet name. Adrienne has Rover and Betty. Ding, ding, ding. Simon has Mimi. Is this relation a function? No. Adrienne, or whatever, has 2 range values. That's not okay, so it is not a function. Moving on here, now we have sets of ordered pairs. So basically we need to figure out if each range goes to or each domain has 1 in the range. So it helps to draw the mapping or to draw the domain and range. Remember that domain is x values. So 2 goes to 3. I'm going to draw it at the same time. 5 goes to 4. 0 goes to 3. And 4 goes to 1. So is it a function? Yes. Only 1 value for each. The domain, we'll just write squiggle bar 2, 5, 0, 4. Squiggle bar. Range set is 3, 4. I guess I didn't need to write that. There we go. I didn't need 2 3s. I didn't see that. So, but still, it's still a function because each one of these goes to 1 of those. So 3, 4. Skip that second 3, 1. All right. So now we need to do it for this one. So I'm going to draw this mapping. The domain 3 goes to -1, 2 to -2. 0 to positive 2, and 2, repeat, this 2 is not a function because this 2 right here goes to both of these values, two range values. The domain, it still has a domain, 3, 2, 0, and the range still has those. It just happens that this is not a function. So on relation 3, let's see. Y goes to Y. You could draw a little mapping here if you wanted. Y goes to Y, K goes to K. But then we have another K going to Y. So this K cannot go to this K and go to a Y. So is this a function? No. This Y goes to Y and it also goes to K. That's not okay. Relation 4. 1 goes to negative 4. No other ones. 2 goes to negative 4. Negative 4 goes to negative 4. And 6 goes to negative 4. But we have different x's. All different. So we're safe. The domain is 1, 2, negative 4, and 6. And the range, they all go to negative 4. But it's still a function. All right. Identify if this one shows a function. So does each domain have one range? No. What's the problem? 8 goes to both 6 and 8 in the range. Over here, 3 to 5, 6 to 5, 9 to 15, 21 to 10. These only have one arrow coming out, so this is a yes. We're safe here. Okay, so we have something called the vertical line test. I think you see some of this on Alex. In mathematics, the vertical line test is a visual way to determine if a curve on a graph is a function or not. A function can only have one output y for each input x. If a vertical line hits the graph up and down, so vertical, more than one point at the same time, then the graph is not a function. It fails the vertical line test. So basically, we're going to draw lines through here, and if it hits our graph in more than one spot, fails the vertical line test and it's not a function. So if I drew a line here, I'd hit it here and here. So this is a no. I could draw one here, here, all sorts of places. This is a no. This one, I draw the whole thing is a vertical line, so that's a no. This one, I could draw a line here, but I don't hit it. I don't hit it twice. I don't hit it twice. I don't hit it twice. Here's my yes. This one, I could hit it right in the middle. I would never hit one here. Here I'd hit it 2 spots, and here I'd hit 2 spots. So the only one that is a function is B. A few more to try there. I could overlap right here. So this is a no. When I'm given ordered pairs, I just need to draw lines through them if I hit dots more than once. So these ones only had 1 dot per line, so this is a yes. This one, no, nothing to overlap. This one is tricky. This open hole actually means that nothing actually exists there. So this line would only hit it here. So this is a funny one, but this is a yes. It's called a piecewise function. This is a vertical line the whole time. No. And this one is a yes. Have a great day.